Welcome to the hidden realm of the universe, where we seek the ultimate cosmic giants, while scientists observe the skies. Advanced computer models expose the mysterious power of black holes. Dare to cross the point of no return into nature's most forbidden zone. Welcome to our neighborhood. The Milky Way is just one of more than 100 billion galaxies in the universe, and our Sun is just one among over 100 billion stars in the Milky Way. We once believed every star, like our Sun, to be a welcoming light in the vastness of space. Now, we know better. The universe holds unimaginable violence, with forces strong enough to rip apart space and time. Join us on a journey to the dark side, straight into a black hole. Cape Canaveral, Florida. Our mission to understand black holes is entering a new frontier. A telescope named SWIFT is aboard a rocket, aiming to track down one of the most elusive cosmic objects, black holes. These celestial phenomena are so dense that even light cannot escape their gravity, making them invisible. Yet today, hopes are high. Scientists are relying on SWIFT to push the boundaries of human knowledge. How do you locate something that hides in darkness? You look for its unmistakable clues. SWIFT's instruments are built to detect bursts of high-energy radiation, gamma rays, which cannot pass through Earth's atmosphere. But in space, SWIFT has a direct view. These gamma-ray bursts occur when a black hole is born, following the fiery death of a massive star in an explosion called a supernova, shining as bright as a billion suns. This process is governed by the force that controls the cosmos. Gravity. Scientists once viewed gravity as a mystical force projected by objects like the sun. But Albert Einstein saw it differently. He described space as a four-dimensional, bendable fabric called space-time, and gravity as the result of massive objects distorting this fabric. These distortions cause smaller objects to fall into their orbits. Einstein's theory was groundbreaking, especially when applied to its extreme. How much could space warp? The answer came from a special class of stars, over 25 times the mass of our Sun, known as red supergiants. These stars live for just a few million years, far less than our Sun. In their core, under immense gravity, temperatures rise to over 1 billion degrees, fusing lighter elements into heavier ones, up to iron. Eventually, the core becomes too heavy, collapsing in on itself and triggering a shock wave. The star implodes into a black hole, while its outer layers explode as a supernova. What's left is a black hole, an object millions of times heavier than Earth, but far smaller. A black hole is like a puncture in space-time. Get close enough, and gravity pulls you in like a riptide, dragging you faster and faster until you reach the point of no return, the event horizon. Beyond this boundary, not even light can escape. Black holes are gravity taken to the extreme, yet they are common in the universe. Dozens have been found in our galaxy, and it's estimated that there are millions more. However, there's another type of black hole, supermassive black holes. Almost every galaxy, including ours, harbors one at its core. The most striking example is the galaxy M87, which has a black hole 4 billion times the mass of our Sun, with jets of energy bursting out at near light speed. To understand where these colossal forces come from, we turn back the clock 14 billion years to the Big Bang. As the universe expanded, gravity shaped everything, pulling gas clouds together to form stars and galaxies. These early stars lived short lives, ending in supernovas, with their cores collapsing into black holes. Over billions of years, some black holes grew massive by consuming gas and stars at the centers of galaxies. Others grew even larger when galaxies collided, merging their central black holes into colossal powerhouses. Astronomers believe that supermassive black holes helped shape galaxies, spreading elements like carbon, oxygen, and iron, the building blocks of planets and life. This raises the question, does our galaxy have one? For more than a decade, astronomer Andrea Ghez has been investigating, using the giant Keck telescope in Hawaii, to observe stars swirling around an invisible force at the center of the Milky Way. These stars are moving at incredible speeds, some up to 3 million miles per hour. Gez's team has concluded that this invisible object weighs nearly 4 million times more than the Sun, confirming the presence of a supermassive black hole at the heart of our galaxy. While we can't yet travel to this cosmic monster, scientists can simulate the journey using the latest observations and models. Leaving the calm outer edges of the Milky Way, we approach the crowded core, where stars, gas, and dust swirl around the central black hole. Its immense gravity warps space-time so much that it acts like a lens, distorting light and matter around it. As we cross the event horizon, we enter the black hole's chaotic interior, where matter and energy are trapped. In theory, black holes could lead to other places in the universe through a wormhole, a hypothetical tunnel through space-time. But even though this idea is popular in science fiction, real black holes are too destructive for anything, including us, to survive. Ultimately, black holes are not just destructive forces. In their early stages, they helped seed galaxies with elements that formed stars, planets, and life. Today, we continue to explore these cosmic mysteries, revealing the dark secrets of the universe.